What might the future hold for sustainable transportation and power generation? Imagine a world powered by hydrogen engines, clean, efficient, and sustainable. But how exactly does a hydrogen engine work? Hydrogen engines begin their journey with fuel storage. Here, hydrogen fuel is safely contained either as compressed hydrogen gas or as cryogenic liquid hydrogen. These storage tanks are meticulously designed to deliver the hydrogen fuel to the engine as needed. Next, the hydrogen gas enters the engine's intake system where it mingles with air to form a combustible mixture. This differs from conventional engines that mix fuel with air in a carburetor or fuel injector. Instead, hydrogen engines typically employ direct injection systems to introduce the hydrogen straight into the combustion chamber. Output. Now, onto compression. Within the engine cylinders, the piston compresses the intake mixture of hydrogen and air. The compression increases the temperature and pressure of the mixture, priming it for combustion. The ignition phase is where things get interesting. Unlike gasoline engines that spark plugs for ignition, hydrogen engines often utilize compression ignition, akin to diesel engines, due to hydrogen's high auto-ignition temperature. Yet, some hydrogen engines may use a spark plug or an alternative ignition method to kickstart combustion. The combustion phase follows ignition. Here, the hydrogen-air mixture combusts rapidly, generating heat energy. This energy propels the piston downward, driving the crankshaft and ultimately powering the vehicle or machinery connected to the engine. After combustion, it's time for the exhaust phase. The exhaust gases, predominantly water vapor, are expelled from the engine cylinders. One of the major perks of hydrogen engines is their minimal harmful emissions, as water vapor is the primary byproduct of combustion. However, nitrogen oxides can be produced if combustion temperatures are high enough. Finally, just like traditional internal combustion engines, hydrogen engines require cooling systems to maintain optimal operating temperatures and lubrication systems to reduce friction between moving parts. In summary, hydrogen engines promise a cleaner and more sustainable future for transportation and power generation. Nevertheless, challenges such as hydrogen storage, infrastructure, and cost remain to be tackled for widespread adoption of hydrogen technology. In the face of these obstacles, the potential benefits of hydrogen engines are too significant to overlook. Who knows? The future of sustainable transportation and power generation might just be powered by hydrogen engines.